Right, we're looking at halogens group 7. That is this group here. So let's get rid of that. It's group 7 and it's fluorine, chlorine, bromine, iodine and astatine. And the ones that you normally will study are fluorine, chlorine, bromine and iodine. These are the ones that you come across the most. Right, it's group 7. So that means it's got 7 electrons on the outer shell. That means it needs one more electron to end up with a full shell. So that means it's going to form a -1 ion. It's going to form an anion, 1 minus, yeah, or -1, -1. Right. What else do you need to know? The reactivity goes down, it decreases. So fluorine is the most reactive and astatine is the least. Okay. We need to learn some properties as well. So let's carry on. Just want to show you this as well. So you've got your periodic table which says fluorine, chlorine, bromine, iodine. What you need to know, right, at room temperature and pressure, it's gas, gas, liquid, solid. Was it gas, gas, liquid, solid? Right, and then here with the liquid you can have a vapor state and a solid you can have a vapor state. Right, so they're gonna ask you gas, gas, liquid, solid. Gas, gas, liquid, solid, and for liquid we've got vapor state, for solid we've got vapor state. Right, that's step 1. Now what you do is, what do you do next? Okay, so think of a angry farmer. He's got his hat on and he's gonna shout at a little fox. Yeah, and the fox is wearing a high-vis jacket and he's jumping over a we've got a grey at the moment, so it doesn't matter. He's jumping over a grey fence and he's chasing a, is that the close I can get? He's chasing a purple chicken. So what it is you've got, he's gonna shout out, "You greedy." What color's the fox? Red, brown. Not red or brown, but red brown. He's wearing an orange high-vis jacket. He's jumping over a grey fence and he's chasing a purple chicken. So the farmer shouts, nice color, yes. He says "you." So "you" is yellow. Greedy is green. Red brown so when it's don't know if that's a good idea, so let's put that over there. That colour's there. You've got an orange, and you've got grey, and you've got purple. Right, so what you have a fluorine is yellow, chlorine is green, so you greedy. Bromine, when it's liquid, is red brown. When it's vapor, it's orange. So you greedy red brown fox wearing orange high-vis jacket jumping over a grey fence. So when iodine, wasn't clever, was it? Is in solid, it's grey in color. When it's vapor, it is purple in color. There you go. So the colors you need to remember are, so let me write this again: fluorine, chlorine, bromine, iodine. You've got gas, liquid, solid, vapor, vapor. Then you have the colors, which are yellow, greedy is green, red brown, wearing orange high-vis jacket. So liquid, when it's a liquid, it's red brown. When it's a vapor, it's orange. Solid is grey fence, grey, and vapor is a purple chicken. You've got to know all this right before we start. Right, okay, let's kick off. Bromine, chlorine, and iodine are elements in group 7. Identify which of these elements has the palest color. So we just said it went from yellow to purple. So yellow is the palest, but they've not given that. So the next palest is green. They've not said fluorine here. Have you noticed? They've not said fluorine. It's just them. So it's going to be chlorine. Has the highest melting point. So remember, it went from right, it went from gas, liquid, solid. So solid is the most obvious one. Has the highest melting point, so it will be iodine. Okay, so give the name of another group element that is solid, so it'll be the bottom one, astatine, in your periodic table, astatine. So they give you a periodic table and you look that up in the periodic table. When chlorine and hydrogen react together, you get hydrogen chloride. Okay. So when chlorine plus hydrogen react, you get hydrogen chloride. So we know hydrogen forms a +1 ion, chlorine forms a -1 ion. Because they're both the same size as ones, we don't need to do anything, so it'll be just simply HCl. Now we need to balance this. So you've got 2 chlorines, 2 hydrogens, you've got that. Remember we said you have something called a diatomic molecule. What's a diatomic molecule? It runs around in pairs. So we said no. And then your halogens. Chlorine, chlorine, bromine, iodine. You just have to mess about. Leave these. Forget astatine. 2, 2, 2. So in the natural world, they run around in pairs. That's where it's useful to know that they're. So then you know you need to balance it by putting a 2 there. Right, let's carry on. So they're saying some hydrogen chloride gas is bubbled into separate samples of methyl benzene and water, blue litmus paper. Right, you've got two things. You've got water and you've got methyl benzene, which is an organic solvent. Okay, so you've got an organic solvent. Right, state with the reason the final color of the litmus paper in the solution in water. So what happens when hydrogen chloride is dissolved in water? It becomes hydrochloric acid. So if that is a gas, right? So this is another question that comes up. HCl as a gas and HCl in aqueous. What are the common names for these? This is called hydrogen chloride here. And if it's aqueous, it becomes hydrochloric acid. Hydrochloric acid. There you go. State with the reason. Right, okay. The litmus paper will be red because it is acidic due to the hydrogen ion being formed. There you go. So 2 marks, red and hydrogen ion. Right. Final coat litmus. Right. What happens is litmus paper. Does it what color litmus paper? Blue. Right. Because it was blue, it will remain blue. It will remain blue because no reaction took place. It didn't act as a solvent. It didn't dissolve in there. No reaction took place. Right. Okay. Let's keep going. Halogens. Halogens are in group 7. Put across. Okay. Chlorine gas is right. Remember we said fluorine, chlorine, bromine, iodine in your periodic table. You greedy red brown fox wearing orange high-vis jacket jumping over a grey fence chasing a purple chicken. Yep. So we're after chlorine gas. It's gonna be green. Okay, so right now at room temperature the physical state of bromine. So remember we said, where's that? We said gas, liquid, solid. So bromine will be a liquid. There you go. Which is the most reactive? So we said reactivity, the reactivity goes down. It decreases as you go down. So the most reactive we're expecting to be fluorine. Right? Okay, there you go. Chlorine reacts with hydrogen to form a colorless gas. What is the name of the colorless gas? So we call it hydrogen chloride. And when you mix it with water, it becomes hydrochloric acid. What's the formula to represent both the, right, okay. So what you'll have to do is HCl. One will be a gas, HCl. One will be a liquid. That's all it is. You just put HCl. You just need to write a formula and just write HCl. Right. Chlorine, green gas, bromine, red brown, iodine, grey. At room temperature. So this is where it comes useful to know that. Predict the physical state of fluorine at room temperature. So look, fluorine's up here, isn't it? So if that is gas, liquid, solid, we're expecting that to be gas. Predict out the color of astatine. Right, it's going to be darker than that. So you just call it like a darker color than that. So call it a dark gray. Because they get darker as they go down color. Right. So look, with this sort of question, you've got chloride and you've got chlorine. You do not react a halogen with its own halide. So that's why, look, you've got iodine, iodide. We don't react those, so we don't do those. Right. You've got fluorine, there's no fluorine, chlorine, bromine, and iodine. Chlorine is the most reactive out of these three. Right, okay. Right, let's carry on. Suggest why there is no reason to add chlorine and to lithium chloride, right? Because you end up with no reaction takes place. And another way of saying it is halogens cannot or don't react with their own halides. Okay. Why is there no reaction when iodine is, right? If you react iodine with the bromide solution, bromine is more reactive than iodine, so it wants to stay like this. So you can say bromine is stronger, so it'll defeat iodine. So if it's more reactive, it's stronger. Right, so we can say, the way you'd answer this is you can say iodine is less reactive than bromine. There you go. Right, name the substance with the brown color that formed when chlorine was added to potassium iodide. When chlorine was added to potassium iodide, right? So we're looking at chlorine and iodide. So chlorine is more reactive, so it kicks out iodine. So you had potassium iodide and you had chlorine. What happens is we said chlorine is stronger, more reactive, is stronger than chlorine. So it kicks out this. So that chlorine will become chloride, so potassium chloride. And that bromide becomes bromine. just a normal element, halogen. So that's the bit that, because it's been kicked out, it's going to give that color. Yeah, so name the substance that, oh, what am I talking? I can't even read. Sorry about that. Because, see, you know, one thing you shouldn't do is cross it out like that. That there says iodide, so iodine. Be nice if I could read my own writing. Right, so what the substance that causes the brown color is iodine. Right, the reaction between bromine and potassium iodide is a solution, is a displacement reaction. What is the correct description of this reaction? Right, I always tend to mess these up. Right, so you've got bromine, you've got potassium iodide, you've got fluorine, chlorine, bromine, and iodine. That's the strongest or the most reactive. Right, I know bromine is stronger than iodine. I can ignore that too. So bromine's going to kick out iodine or the iodide. That goes over there. No, I'm not going to do it this time. I'm just going to put a line through this so I don't mess up. So that becomes, so this iodide becomes iodine, and that bromine becomes bromide, so it becomes bromide. So you end up with potassium bromide. So what we say is a bromine displaces iodine. So bromine goes in there and it's kicked out the iodide ion, but it's the one that's been kicked out, or what is formed is iodine. So it's this one here. So remember, it's not bromide. It's not bromide. It's not bromide. So it's not definitely not those two. And it kicked out the iodide ion, and the iodide ion became an iodine ion. So what was displaced was iodine. So it's not that. So it's D. Right, okay, complete the chemical equation. Cl2, right. We know bromine's displaced, and we know bromine is diatomic. So we've got two bromines there. And we know potassium chloride is KCl, because K forms a positive 1 ion, chlorine forms a negative 1 ion. They're both 1 1, so it becomes KCl. But we've got two of these, and we've got two potassiums as well, so we stick a big 2 there. That's what we're doing, is balancing the equation. Right. Right, let's try to squeeze this one in. Bromine, chlorine, fluorine, iodine. They're all in group 7. They are called the, what are they called anymore? What's group 7 called? The halogens. Or some people, I've heard it called halogens. I don't know. I think it's halogens. Which of these two elements are the darkest? So remember we said okay, fluorine, bromine, iodine. We said it's gas, liquid, and solid. Because that's a liquid, you need a gas. Because that's a solid, we need a gas, but we use vapor states. And then the colors kick in, don't they? You greedy red brown fox wearing orange high-vis jacket, jumping over a grey fence, chasing a purple chicken. So yellow, green, red, brown, orange. What color Which is the darkest? Okay, so we can say iodine is the darkest and bromine. Iodine and bromine. The equation is hydrogen and chlorine is H2 plus Cl2 gives HCl. Right, remember we said one's a gas and one's a liquid, an aqueous liquid because it's been dissolved or mixed with water. It's been dissolved in water. So you've got, with the gas it's called hydrogen chloride. With this one is called hydrochloric acid. Right, okay. The presence of HCl can be confirmed by adding ammonia. Right, okay. Remember what we said about ammonia and ammonium. NH3 is a ammonia. It's a covalent molecule. Ammonium is ammonium. Ammonium is what? It's an ion. It's a positive ion. Right. Right. So what are we expecting? I think this reaction you've got to know anyway. So you've got cotton wool soaked in hydrochloric acid, and you've got cotton wool soaked in ammonia. What happens is things evaporate that way and they'll meet. Let me have a look. 1 second. Right, so what happens is you get a white precipitate of ammonium chloride here. So that means this travels further than this. It's closer to the hydrogen chloride gas. So these are smaller molecules in molecular mass. So they travel further, faster, because they're lighter. And so you'll get a white ring here. Right, so what we're expecting a white solid or white smoke appearing here. And the reaction would be ammonia plus hydrochloric acid gives ammonium chloride. Right, so if you just check that they're all balanced, so you've got 3 hydrogens, 4 hydrogens here, and you've got 4 hydrogens here. 1 nitrogen, 1 nitrogen, 1 chlorine, 1 chlorine, so it balances out. Right, so now they're saying in the presence of chloride ions, HCl can be shown by mixing it with silver nitrate and dilute nitric acid. Right, so the test, and then again you've got to learn this, the test for group 7 or halide ions is you would mix your halide ion with silver nitrate, and you're going to end up with 3 precipitates, yeah, for chlorine, bromine, and iodine. We're not interested in fluorine. The way I look at it, fluorine is too reactive for the lab, so we ignore it. So when you add silver nitrate to any of these 3 ions, you're going to end up with a white ice cream with a hint of lemon. So the way I see it is you're going to get a white precipitate, you're going to get a cream precipitate, and you're going to get a yellow precipitate. So we're looking for chloride ion. So we're expecting a white precipitate. I like to call it PPT for short. I'm sure I've seen that somewhere. Right, okay. Sodium nitrate will be aqueous. Hydrogen chloride when it's aqueous is hydrochloric acid, and you end up with a solid precipitate, and HNO3 is nitric acid, so you can have that as aqueous. Right, let's keep going. Right, solution X is made by dissolving HCl gas in water. Solution Y is made by dissolving HCl gas in methyl benzene. Methyl benzene, is good to know that it's an organic solvent. Okay, a student added magnesium ribbon and blue litmus paper to separate samples of each solution. Right, that's going to be acidic. That's going to be hydrochloric acid. Right, so what's going to happen is you're going to get a metal, which is magnesium. You're going to add an acid, and you're going to end up mash out. You're going to get salt and hydrogen. So what are we expecting? We're expecting bubbles. What's another posh name for bubbles? Effervescence. Right, metal acid gives salt and hydrogen. Right, okay, so magnesium ribbon was added and you ended up with bubbles. So we know you've added it to the acid, which is HCl water. And blue litmus paper, right, blue litmus paper turned red. So that means it was acidic. There was no change and it stayed blue, so that means it didn't dissolve in, well, it didn't dissociate. It didn't break up into hydrogen ions and chloride ions. What substance is responsible for the bubbles? We know it's the hydrogen. Yeah. State one change to magnesium ribbon that could be seen after adding it to solution X. It becomes smaller. Or if you left it long enough and there was enough acid, it would totally disappear. Oh, it'd be nice if I could spell. Right, let me write that again. Not to confuse this here. Single S, double P. Right, what color change of the litmus paper does it show about solution X? So solution X is acidic because it contains the hydrogen ion. So put both in. It's acidic because it contains the hydrogen ion. Why does litmus paper stay blue? Right. Right, you can get away with saying there was no acid formed, but the one that I prefer or like is to say hydrogen chloride did not dissociate, break apart, or did not ionize. That makes more sense to me, but you can get away with no acid was formed. Right, we're going to stop there. We are going to stop there. Right, okay.